Now we will discuss some questions on states of matter. So we have to once again bear it in mind the concepts behind the states of matter. Boyle's law, Charles' law, ideal gas equation, these are to be definitely noted. Now this is actually based on elemental things. Anyhow, we will see from the thing. The question reads as the plot means graph. The plot of volume versus temperature for a gas at constant pressure is a straight line passing through the origin. Now it is written in a condensed manner. What actually reads is that the plot of volume versus time temperature for the gas at a constant pressure is a straight line passing through the origin. Which of the following orders is correct for the gas? There are some 4 orders mentioned. Pressure is greater than, or pressure is less than, or pressures are equal, or 2 pressures are only equal. Some conditions are given, but the figure also given. So plot of volume versus temperature, whenever it is mentioned like this, general pattern is that first one will be dependent variable, that will be plotted on y-axis. Y-axis is the volume, x-axis is the temperature. Volume versus temperature plot means y-axis volume, x-axis temperature. So this plot shows the variation of volume with respect to temperature at different pressures. So at constant pressure, at a constant pressure P1, at a constant pressure P2, like that it is given. So 4 plots are given. From this we have to analyze. So some 4 orders are given, which is the correct order has to be chosen. That is the question. Now 4 orders are given as 4 choices. For this analysis, let us fix a line parallel to volume axis. Line parallel to volume axis. Correspondingly, we can mark the respective volumes. So this is the bottommost straight line is the plot at constant pressure P4. Corresponding volume, let it be V4. Similarly, the topmost line is the volume versus temperature plot at constant pressure P1. The corresponding volume, let it be V1. So for the same line, parallel line means it bears a constant distance between the volume axis. So same distance from the volume axis. So 4 different volumes are V1, V2, V3 and V4. These are nothing but 4 different values of volumes in this plot. So from this we see that these are V1 is nothing but y-axis distance, y coordinate, abscissa ordinate or however in the max. X distance is called abscissa, y distance is called ordinate. So y coordinate V1, V2, V3. From this graph we observe that V1 is greater than V2, is greater than V3, which in turn is greater than V4. So this is the trend. V1 is the maximum volume. So all the gas laws are based on Boyle's law. So first one is the Boyle's law. Boyle's law states that pressure is inversely proportional to volume at constant temperature. Pressure is inversely proportional to volume. So at constant temperature. So here volumes are decreasing, which means that pressures should be, volumes are decreasing means pressure should be increasing order, in the increasing order. So for this plot, application of Boyle's law fixes the correct order is that of C. C reads that. So the C order and what we have deduced from the graph. Go inside together. P1 is less than P2, less than P3, less than P4. So other choices are not possible. Definitely it is measured at different pressures means these pressures cannot be same. And different pressures means no 2 pressures can be same, like that. Lastly, pressure is, from the graph it may appear that pressure decreases P1, P2. These P1, P2, P3 values are neither x-axis distance nor y-axis distance. They are given some values. That is to be noted. We have to analyze only in terms of volume and then apply Boyle's law. So this finishes or fixes the correct order for this C. So all these are lines passing through origin, that is also given. So in this For the reference purpose, figure is given. In some cases, they may give this as such. You will have to draw because it is the notes are given. It is a straight line passing through the origin. So we have to draw 4 different lines and then you have to mark. That is to be noted. Here, as per the figure, this is the correct order to be noted. Now, this question is based on the application of Boyle's law. So, this question reads as, a person living in Shimla observed that cooking food without using pressure cooker takes more time. The reason for this observation is that at high altitudes, there are 4 choices given. So, they have illustrated the use of pressure cooker at higher altitudes. Generally, we have to note what is the principle of pressure cooker. Pressure cooker we tell. But actually for cooking food, heat energy is required. But we are calling it as pressure cooker. Why it is called? Because of increased pressure, water is made to boil at high temperature than the expected one. Normal boiling point of water is 100 degree. So 100 degree. But at high pressure, inside the pressure cooker, pressure is very high, so that water would boil at higher temperature. Higher temperature means it will take more heat energy or deliver more heat energy to the item to be cooked, so that it is finished in fraction of a time or lesser amount of time. This is the principle of pressure cooker. But here it has been told that without using pressure cooker normally. It observes that a person living in Shimla, hill place. So hill place means high altitude place. So at high altitude places, he observed that cooking food without pressure cooker takes more time. Here he is not using pressure cooker. So cooking food means with normal conditions, it takes more time. This observation, reason for this observation, it is given. 4 choices are given. At higher altitudes, whether the pressure increases or whether the pressure decreases or pressure is not altered or none of the cases. 4 choices they have given. They have to analyze the choices. We know that acceleration due to gravity in physics study G varies from place to place. G is acceleration due to gravity. It's like, so average value is 9.8 meter per second square, but it varies slightly from this value from place to place. At high altitude place it is different. That is the reason. So here we have to note that at high altitude, first we have to note down the point. What is meant by boiling point? Boiling point is the temperature at which vapor pressure becomes equal to atmospheric pressure. This point has to be noted. Boiling point of water is 100 degree we tell. What does it signify? At 60 degree also water will boil. At 50 degree also water will boil. But we tell boiling point of water is 100. What is the significance is that only at 100 degree vapor pressure of water equal to the atmospheric pressure. Atmospheric pressure is 760 millimeters mercury or 76 centimeter mercury. So 760 millimeters mercury pressure is obtained only at 100 degree for water molecules. That is why it is said to be at a boiling at. So boiling point is the temperature at which the vapor pressure. Technically we have to note boiling point. It is not merely a point at which it boils. Every temperature, every system will boil. So even in common words, his blood boils. We cannot call it as boiling point. So that is to be noted. Boiling point is the temperature at which vapor pressure becomes equal to atmospheric pressure. So at high altitudes, this vapor pressure is lowering. That is why pressure is directly proportional to temperature. Pressure is directly proportional to temperature, or lowering means at high altitudes. Actually in physics you might have studied this relation. P equal to rho GH or gamma H, whatever be the case. There are 2 formulas. One is called gamma H or rho GH. Rho is the density of the liquid for the measurement of pressure. G is acceleration due to gravity. H is the height of the column. Rho G is also denoted as gamma. P equal to rho GH one formula or P equal to gamma H one formula. Rho and G are constants, which means that P is at directly proportional to the height of the column. It has nothing to do with the altitude. That is to be height of the column with which pressure is measured. We measure pressure in terms of 760 millimeters mercury. So at high altitudes, low vapor pressure means pressure of water is getting decreased. Wow, low water vapor pressure means temperature is low. Low temperature means you have to supply excess heat energy to cook the food. Temperature is the effect, heat is the cause. So required amount of heat has to be supplied. That will be supplied only in a longer time. Only during a longer time. Energy required, heat energy required for cooking is fixed. But at high altitudes, it takes greater time to realize this heat energy. That is because the pressure decreases. Pressure decreases means atmospheric pressure value decreases. Normal atmospheric pressure value is 760 millimeter. At high altitudes, it is less than 760. If it is less than 760, vapor pressure is lowered. That is, vapor pressure of water is lowered. If it is to be equal to atmospheric pressure, it has to be heated further. It has to be heated further. That is, pressure is directly proportional to temperature. We have seen. This is one of the formula for behind the Boyle's law and Charles law. From this, we see that pressure decreases. At high altitudes, pressure decreases. That is why without the use of pressure cooker, it takes longer time. So for this question, the choice is pressure decreases. Actually here it is written in the condensed version. Upward arrow stands for increases. Downward arrow stands for decreases. Remains constant. None means neither increase nor it is not again. Just to finish, the choices are given. For this, correct choice is lowering of pressure at high altitudes. It is the general expectation, even otherwise, that is to be noted. Now, next question is based on the molar volume concept. So, we have seen that molar volume is volume occupied by 1 mole of gas at STP, or STP is standard temperature and pressure. Temperature is 273 Kelvin and pressure is 1 atmospheric pressure. So 1 atmospheric pressure 273 Kelvin or 0 degree centigrade, ice point is called standard temperature pressure condition, STP. NTP means normal temperature. Normal temperature is not 0 degree, it is 27 degree. So 27 degree and 1 atmospheric pressure is called normal temperature pressure. 0 degree C or 273 Kelvin is STP. Now this question reads as a gas that follows Boyle's, Charles and Avogadro's laws. All the laws. The gas follows all the 3 laws. Boyle's law, Charles law, Avogadro law. Is termed as ideal gas. They have given the definition itself. What is meant by ideal gas? Under what conditions a real gas would behave ideally? Under what we call it as, call the gases or as ideal gases and real gases. What is meant by ideal gas? They have given the definition. Ideal gas is the gas which obeys Boyle's law, Charles law and Avogadro's law at all conditions of temperature and pressure. Let us recall once again. Boyle's law, simplified version, pressure is inversely proportional to volume at constant temperature. Charles law, pressure is directly proportional to temperature or volume is directly proportional to temperature. Avogadro number, 1 mole of any substance, any gas, 1 mole of any gaseous substance contains Avogadro number of molecules, that is 6.023 into 10 power 23 molecules, irrespective of any gas. 1 mole of that gas, you have seen about the basics of chemistry, even number of moles equal to weight by molecular weight. You convert in terms of mole. 1 mole of any gas will contain 6.023 into 10 power 23 molecules. Similarly, 1 mole of any gas at STP will occupy 22.4 liters. These are called laws. If it obeys these 3 laws, it will be termed as ideal gas. But in practice, some of the gases are not obeying this law. Such gases are called real gases or which have deviations from. So, what are the conditions for ideal gas? They have given. This is to be noted. When a gas will behave ideally. These are to be known. Already we have seen. One is effect of pressure, another one is effect of temperature. At low pressure and at high temperature, molecules will behave ideally. At low pressure, these are the conditions. Already we have seen. Low pressure and high temperature. Why it is so? When a gas will behave ideally, when the gas molecules are free enough to move about it. If the gas molecules are free enough, that is said to be ideal gas. No influence of any other force. They can be freely moving. Free movement of gas molecules is possible under which condition? These conditions. Low pressure means pressure is inversely proportional to volume. It is one of the conditions. Low pressure means volume is high. Pressure is low means volume is high. Volume is high means enormous volume. Initially, the gas was kept in 1 liter. The same gas, if it is converted to another cylinder of 2 liter, number of molecules is same. The same number of molecules are distributed now in 2 liters. Same number of molecules are distributed in only 1 liter. Means that enormous space is available for them, so that they can move freely. We can think of this situation. Whenever a bus or train, if it is not crowded, everybody will be free enough to move then and there. Here also gas molecules will be free enough to move at low pressure or high volume conditions. That is to be noted. What is the effect? Similarly is the effect of high temperature. When gas molecule is heated means its temperature is increased. If the temperature is increased, already we have seen about kinetic energy. Kinetic energy equal to 3 by 2 RT for 1 mole of gas. Or in other words, kinetic energy is proportional to temperature, we have seen. Higher temperature means higher kinetic energy. Higher temperature means the two conditions. One is effect of pressure, another one is effect of temperature. So, effect of temperature, as temperature is increased, kinetic energy is increased. Kinetic energy is nothing but of mv squared. Mass of the gas will not change. Only the velocity of the gas will change. If the velocity of gas changes means gases move fastly. They are quite free enough. Escape the container. So that is also the case of ideality. So if the freedom is maximum, it is said to be ideal. The maximum liberty or freedom is possible for gas molecules only under these two conditions. Low temperature and high pressure. These are to be noted. Actually the question reads, a gas that follows Boyle's law, Charles law, Avogadro's number or Avogadro's law is called ideal gas. Under what conditions a real gas would behave ideally? At high pressure, first choice is given as high pressure, opposite choice is given high pressure and low temperature. Means that high pressure means volume will be very low. Volume will be very low. If the volume is very low, molecules are brought closer. If the molecules are brought closer, intermolecular forces are greater. Even in physics we have studied, F is directly proportional to and inversely proportional to square of the distance. If the molecules are brought closer, the force increases. Smaller distance, so intermolecular force increases means molecule cannot move. If it is not cannot move freely means it lacks ideality. So at high pressure it will not behave ideally. Similarly at low temperature means also kinetic energy is decreased. Kinetic energy equal to half mv squared. So half mv squared is decreased. M will not decrease. Only v squared will decrease. If v squared decreases, v also decreases. Velocity decreases means the molecule will move with lower velocity. Or in other words, molecule moves slowly. If the molecule moves slowly means that it lacks liberty. If it lacks liberty, ideality is not there. So ideal behavior, this condition is not there. These two conditions, high pressure and low temperature, conditions for real, normal, real behavior, ideal behavior. So first one is not there. Second choice is actual choice, that is low pressure and high temperature. Third choice, one of the both low, both high, they are given. Both high means high pressure and high temperature. High pressure is not correct, high temperature is correct. Fourth choice is low pressure and low temperature. Low temperature is not correct, low pressure is correct. That is to be known. Here you can compare. So you got to carefully note down these two conditions, essence of the condition for ideal behavior, low pressure and high temperature. If you carefully analyze this situation, the correct choice can be marked. So in this question, this choice is given as choice B. So choice B is the correct answer for this question. Now this question is based on the concept of molar volume. Actually this question reads as the volume of nitrogen and argon at 273.15 Kelvin and 1 atmospheric pressure is dash. So it is condensely written volume of nitrogen, volume of argon at STP equal to dash. It is given. So nitrogen N2, argon AR. So from the symbols it may tend to confuse. That is argon contains only one atom. One molecule contains one atom only. Whereas nitrogen, one molecule contains two atoms. Molar volume, volume occupied by the molecule or mole, these concepts. But you got to note that N2, so there are four choices given. A is 11.2 liter. All these are dash liters. Actually the question written is volume of nitrogen and volume of argon at 1 atmospheric pressure and 273.15 Kelvin is dash liter. Four choices are given. First one for nitrogen, not one for, first one for nitrogen, second one for argon. So nitrogen contains 11.2 liters, argon contains 22.4 liter, it is given, one choice. Second choice, both volume occupied is only 22.4 liter. So really different choices are given. So similar, same volume is given for both, but numerals are different and opposite volumes are also given. Here also molecular formula is also differing. So it tries to confuse, but we have to bear it in mind that 1 mole of molar volume concept, 1 mole of any gas at STP occupies 22.4 liters. That is nitrogen N2 means 1 mole. Argon AR means 1 mole. This atomic weight and molecular weight is same for argon, but atomic weight and molecular weight are different for nitrogen. It is not the question. 1 mole means 1 mole. It is N2 means 1 mole of nitrogen. AR means 1 mole of argon. Both are gases. So the law molar volume concept states that 1 mole of any gas, whether it is nitrogen or argon at STP, would occupy only 22.4 liters. So for both the gases, it is only 22. Any gas it is given. 1 mole of any gas. Statements reads that irrespective of monatomic, diatomic, you can list any number of gases here. Ammonia, methane. The condition is that they should be in the gaseous state. That is to be noted. So ammonia, methane, nitrogen, oxygen, ozone even, irrespective of their formula, 1 mole of any gas at STP would occupy 22.4 liters. N2 is gaseous specimen, argon is also gaseous specimen. So they occupy the same volume 22.4 liter. This finishes the correct choices for this question. Now next question is based on the ideal behavior. We have studied about compressibility factor. So compressibility factor equal to PV by RT. PV equal to RT. PV is greater than RT or PV is less than RT. Accordingly it is called compressibility factor. So compressibility factor, what happens to the compressibility factor at high pressure, it is asked. So the question reads as Z stands for compressibility factor. So it briefly the question is written as at high pressure the compressibility factor is dash. It is given. 4 values are given: unity, less than unity, greater than unity. Compressibility factor is 0. Compressibility factor is 0 means gases cannot be compressible. That rules out. They are compressible, but they are compressible to a greater extent 1 plus, lesser extent 1 minus, normal extent 1. That is to be noted. Which is to be here we have to make use of Van der Waals equation. Van der Waals equation is P plus V by A by V squared into V minus B equal to RT for 1 mole of gas. So PV equal to RT is the ideal gas equation, but all the gases will not behave ideally. This is called a real gas equation for any gas. Any gas will obey this Van der Waals equation. He took into account the correction terms. So at high pressure means volume is very low. Boyle's law will definitely be obeyed for any gas. So high pressure will be, volume will be low. Volume is low means you cannot discard B. B is not negligible compared to V. But in the case of high pressure, pressure is very high, so that A by V squared is considered as negligible. Let us illustrate with the example. Pressure is 100. A by V squared is 0.01. It is almost equal to 100. 100.01 or 100, both mean the same. But here it is 0.1, it is 0.01, means you cannot neglect. Here B cannot be neglected. If the volume, so at high pressure means pressure is very high, so that A by V square term is negligible compared to pressure at high pressure. And the addition only, that is to be noted, addition or subtraction which is negligible or not. Multiplication you cannot neglect anything, that is to be noted. Multiplication or division, only some terms are negligible during addition. For example, 100 plus 0.01 is almost equal to 100, but 100 into 0.01 is not negligible. That is to be noted. But here 0.1 minus 0.01 is not to be treated as negligible. For this case, this equation can be written as, if pressure is very high, this term can be neglected. If it is neglected, can be written as P. So P into, here we have seen that B cannot be neglected. B is very low. P is also low. So if between two values you cannot neglect both. P into this equation. Actually the idea is that Van der Waals equation is reduced to this form at high pressure. That is to be noted. At high pressure, pressure is very high compared to A by V squared. So A by V squared is negligible compared to P, but B is not negligible compared to V. That is to be noted. RT is there. Now simplification. PV minus PB equal to RT, or PV equal to RT plus PB. So you can divide completely by RT. RT, RT, RT. PV by RT is nothing but compressibility factor definition. RT by RT is 1, P by RT. So compressibility factor for this case, high pressure case, is 1 plus PB by RT, which is given as the third choice. So similarly you can work out for high volume, low pressure condition. In the case of low pressure condition, volume is very high. If volume is very high, A by V squared is very low. A by V squared is very low. Under this case, you have to properly take into account whether it comes in the denominator or numerator, addition, or so. In every case, it cannot be neglected. What are the cases? So for this question, at high pressures, compressibility factor is given as 1 plus PB by RT, where P is the pressure, RT values, gas constant, temperature, B is called Van der Waals constant. A and B are called Van der Waals constant. So Van der Waals constant will not be same. It is varying from gas to gas. That is to be noted. There are different constants. One is called R, gas constant. Universal gas constant means it is applicable for any gas. It is only 8.314. But Van der Waals constant A and B are not same for all the gases. They vary from gas to gas, because it is some gases behave ideally, some gases do not behave ideally. Accordingly, Van der Waals constants will differ from gas to gas, but not universal gas constant. These points are to be noted. So this finishes the treatment of this question.